This video will introduce the new version of KherveFitting version 1.62. The reason I called it version 1.62 is because we are close to version 1.7. I've already started doing an automatic server identification. So version 1.6 offered now import-export of fitted Casa XPS and especially a better background management. So this is now, this was lacking before, and now this come to as good as the background management as Casa XPS. I will show it later. So KherveFitting comes with all the improved tools that we have been enjoying before. The main one being the sample manager. We still have the same look and similar icon, but we've added now a subtraction of files of core levels, a summation of core levels, and a fitted. We can now plot fitted core levels. So with this one, you can obviously plot the data or offset the data, and if you multiply, you just increase the offset, you wait a little bit and the offset is down. But you can also doing fitted stack plot, and you can increase the offset the same way. You just wait, and then you can decrease the offset by left clicking. Okay, so you can also add samples using these new tools. So if you have a new sample, a new file, you can go and get it and just copy it, and this will appear in the sample manager. Another way, by the way, of copying files is to open a new instance of KherveFitting. So right now, I've just reopened a new window, and here you can add a new set of data, let's say a big file like this one here. And if you feel this is too many windows, too big windows, just minimize them. Just minimize them. And let's put them next to each other. As long as we see the sample manager, we can copy data. So copy core level from one to the next. This will take a while if you have many files or pages like on this one, but there is another way of creating multi-samples files, is simply to drag 2 or 3 or 4 files together. So for example, in here, as long as they are KherveFitting, you put them inside like 2, and it will ask you what you want. So I'm just going to create a combined one. And now the combined files is shown here with the 2 files. So there are different ways of adding core levels together. Now, obviously, KherveFitting allow you to fit the data. And I will show you as an example, for example, on oxygen. So here we have a data which was fitted before. I can remove absolutely everything. So now you have, let me just minimize this window. You have those V-line, vertical line that I talked about, and they will always appear. So if you remove that, they will appear, or they may be at the back. So if you put them here, you create a region, and this will be now on the smart. There is no more multi-region smart because you can create multi-regions using this button here, just like you would do on Casa. So now, if I just go down using the control down button, I can simply change the data, and this will change the Shirley, just like you would do on Casa. I can obviously change the offset using the Shift key, and it will never go above the background, but you can change all this. And you can also do it through this button here. So let's say now I'm at 542. If I just go down, you see now where my key is, somewhere there at 500. If I press the down button, I'll be at minus 642, minus 742. So that makes it quite simple to change. So I can increase just one, and maybe 900, and so on and so on. And you can do the same for left or right. You can do the same for the regions. Let's say now if I increase, decrease, now you can just continue and do it through the key control, which is sometimes much easier. This is how you create pics. Now let me finish it by just removing the current regions and maybe simply create a new regions and create pics. So now the default is the SGL. The SGL is very much like a void. So for new users, is the best pic model to use. So I'm going to create in here 3 pics because I know there should be 3 pics. And then you would make pick B and C in function of A, just like so, with the full width self maximum on the Lorentzian to Gaussian. You'll fit and you wait for the fit to finish. Okay. This is how now we can do those fit. Make sure you change the settings here. If you the pick label, you can obviously change that afterwards, but like this. And now if you have the correct pick label, then only the name will appear. So that's how you do a normal fitting. But let me show you now with something more complex on why the background is now quite good. If I go to my general file, which is a list of core levels that I have from every type. So let's look at the Cerium 3D. Here it's a bit more complex. Now if I just open this pick fitting, you're going to see that I have 3 regions, and I can switch between each using this switch tab or the switch region, which is also the tab key or the Q key. Okay, so now I could simply change this one by moving, and now you can see that the region is changing. So that's much easier than before. And I could just offset the same way. Yeah, or simply use like what I showed before. If you want to remove a region, you have to just select it. Let's say I select this one, and you can remove the current region. And now the background is gone, but the background is actually equal to the raw data. That's why it looks like this. I can create a new region, and the first region usually it tends to be equal to the region 1. So if I go in here, this is now selected, and I can put that back somewhere there, and now you get the new region. I can simply change the offset, and if I want, make it very precise using the shift key button. Yeah, so this is offset right. I can go slowly, 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 or faster. So that makes it extremely easy to use. Okay. The same, as I explained, is for those settings here. Okay, so now we are going to show obviously all the different tools that we have. We have the label, which is shown here. We can create new label and add them somewhere, add them at 90 degrees, move them as we wish, and they appear on this grid there. We can remove them as we wish, obviously, remove them all, and that will be very useful for surveys. So now, for surveys, we simply go into here, and I will introduce you to the new automatic ID. So this is a titanium type samples, titanium oxide, and we can see some sodium, carbon, and maybe that is it. So now we have this automatic ID. We used to have this manual ID, and it's still available. So if I show titanium, you can see that you have the titanium 2P and 2S, 3P, 3S. And if I simply click on this one, now we come to this type of management. It's usually all parameters have been optimized, so you don't need to change it. But here we have a text box, which is for now here because this is not a perfect auto ID. So if you know what you have, it's often best to just put it in there. So now we run the auto ID, and as you can see, it found most picks: titanium 3P, 3S, carbon 1S, sodium KLL, and he hasn't found the titanium 2S. So we can just tell him. We can just say, look, we have titanium. We know we have. So now we get all the picks that we expect. And from that, we can select the regions. We can create areas, create labels. So for example, if I just deselect them all and just create the carbon 1S, yeah, I will just create a label, and now you have the carbon 1S here. Or if you wanted them all, deselect select all, and create the labels. So now they're all there. And again, they're all appearing in the label managers. So let me remove them all again. And you can do the same with create area. I do not recommend to create all areas because some are not needed really. So deselect them all, just select the carbon and the titanium 2P, let's say, and maybe the oxygen. And now you can create the area, and you can just check if you are happy with it. So this is again not optimized, but if you use so as you can see, if you use now the edit area, which goes back to this button here, then you can actually switch tab and play with the areas. So now, as you can see, we have many windows, but let's go into the one. So we again, this to change the region, switch tab. So we go into at the beginning just 95 to 10 to 90% of the screen, and then he will switch to different ones. So let's say oxygen, titanium, carbon. So if we want to change that, just go up to here. It's not going to do it automatically. Just make sure it's carbon 1S, create the background, and it's done. Now you go back, look for oxygen, and we can just use the tab key again, and the oxygen is there. We can zoom to it. Sorry, zoom to it. And now this is, if we set it somewhere here, making sure again it's oxygen 1S, we can just optimize this and do the same for titanium for titanium 2P. Check if it's good. And no, it wasn't so good. Maybe we'll add this, but then you can see that this is now, I think it's ruthenium 3P. So we add that here, and now we have titanium 2P, and they're all together. So this list here is a list that is available through the core level list. And then you can see what's coming up. So now I could, for example, zoom out, and I could just use my control key and move all those together. So all this is again new. It was not there before in the version 1.54. So I have my control key pressed. If I don't have my control key pressed, I then can only move one, and then my regions increase. And if I press my control key again, I can have them all together. So, for example, if I go here, I get my iodine 3 acid believes, but if I just go a bit closer, it's mainly sodium 1s. And here, if I didn't have it, I could just create a background. And now this is coming up. So if you want to know the range, you simply have to export it now into the results grid. And like this, you can just check what you have. So for example, if I have TiO2, which it looks like I have, this is close to TiO2 or close enough. And now let's just look at the different type of surveys I have to just show the possibilities or the capability of the automatic ID. So I have all those types, and that's what I've been training the thing with. And for example, if I go, so this was titanium, and this is slightly harder. Let me show you later. This is the one that fails the most. But let's say something like this, where you would not know what you have. So you run the auto ID, and now it found. And if you just click on them, you just go in between like this, aluminum 2p, aluminum 2s, and carbon 1s, and then he failed afterwards, some of them, but the titanium 2p one have, yes, that's correct, oxygen 1s, and so it's pretty good, yes, it's pretty good. Now, if you check something else, let's say maybe this is manganese, so let's run it again. He believes sorry, this was actually, was it manganese? Let me just check. Yes. Let me just, yeah, 710. So it's iron actually. And that's what you were expecting having. So it's actually iron. And yeah, I wasn't aware, but you can see it's working well. And if you think that you know exactly what you have, we can see here, this is iron. So let's just add simply iron in here. You run again, and then you get extra picks that have, because now it's so sure it's iron, you've told him it is. So that's what this thing is good for. If I now look at others, let's say something like this is the zirconium, which I want to show later. This is vanadium. So let's say vanadium will fail. If I run this, it will find, okay, it find also vanadium, but it's not great. And you see, he's thinking that there is zinc and so on. So tell him simply, sorry, I've told him there is iron and there isn't. So let me just ask again. And he found maybe zinc, but it's not. And we can see in here, if I just remove this one right there, we can see in here that you have 1000. So sorry, I'm trying to get this binding energy shown. So this should be, yeah, sodium 1s. So it failed for sodium 1s. But now, let's say now we know we have vanadium. So let's just put vanadium, and now you get all the peaks in here, but you didn't see this peak here. And that's definitely sodium. We know because we have sodium 1s on sodium KLL. So just add Na. And now you have them all together. You can just do Na1s. And this will just look for Na1s in here. Okay? And so that's how it works. Now let me just do another example. This is maybe something more normal, a dirty sample. So let's just run that, empty this time, run auto ID, and he found, yes, phosphor 2p2s, calcium, oxygen, and a bit of fluorine and sodium. And if I now look at something that doesn't work too well as far as I see. Let me find first, yeah, the zirconium. So this is zirconium 3D. If I tell him to look at that, he will not find it because there is something like calcium around it. So now, and he hasn't found the big one. So you can use the edit area in here and have the core level list if you like. And you can make those ones smaller like this. Use the control, go around there and see maybe the zirconium 3D is there. And it was also available in the find picks. So if I was just going into here, let's say he found, yeah, he found in here all those ones with zirconium 3D appearing. So you knew that there was maybe zirconium. So then you just put zirconium in here, and then the results is now absolutely sure that all those ones are zirconium. Okay. So this is one thing that's been added. Another thing that has been added, for example, is the seekogram. So, for example, in here, if you have, let's say, some data in the results grid at row 0, so this is just row 0, then you can look for thickness. Obviously, this is not a proper sample because I don't have a thin film. So I have area of strontium on the area of carbon. I could go into the seekogram and tell him right there that my overlayer should be carbon. So let's say my CC. And my underlayer is the strontium because it's STO. And then I can calculate and get an expected thickness. And in this case, he believes that there may be 1 nanometers. So this is a beta version. It really needs to be looked and checked by a super user. And the help will explain you what the seekogram is about and who made it. It doesn't come from me. This is available on the web, but this is just adding it to KherveFitting. Another thing that was added is the valence band, so the calculation of valence band. So if we go into File, you can go into the example, and it will go into all the folders that we have. And in here, we have valence band, and let's just go to valence band, and let's start maybe with the Fermi. So let's say if you get a Fermi edge, sorry, yeah, that's it. If you get a Fermi edge in here, then you can, let's redo it. Let's remove the regions, absolutely everything. And the way you now look for the Fermi edge is using this VBM. And this will have two lines, and you can just put it in between. And this will calculate the Fermi. And it will look for the center, and obviously this may be not perfect, so you can just try somewhere in between and refit the Fermi, and as you can see now, you get something at O of 0.177 from the 0, and the 1684 is given, and there is also a report with the 1090, 1684 on the 2080%, and so that kind of gives you a resolution of your instrument. Okay, so obviously we like to do also VBM measurements. So this is done, let's say, looking at the background extrapolation on the valence band minimum shown here for gold. And so you can use again the VBM. Let me remove absolutely everything. So let me remove the VBM like so. And so now you have to look at the minus 0.22 on the 13.38 because one is for the valence band minimum, the center edge, the center of the edge, and one can be for the background. So for now, we won't tick the background, so that actually is not needed. But basically, I can just go here, calculate the VBM, and it will extrapolate to the 0. And that gives me a value of the extrapolation, and it used 10 points. So I could use 5 points, 12 points, however I want to use. Now I can also extrapolate the background, and let me just put that in there. And we put my edge, maybe I'll add 20 points for the background, and we can recalculate the VBM like so. Now you can see how many points, you can see how nicely this was done. You can maybe check if if the background was well done, and the VBM is shown here. It's the intersection of the points. You can do the same with the cutoff to measure the work function. And this is, again, using the same one here. So those are mainly all the functions that have been added in the last months, and there are more, but it's not important. Obviously, we have the D parameters for the sp2 carbon, measuring the amount of sp2 to sp3. We have an order to sort pages. For example, if you go into the STO3, you may look at your files, and it may be a mess. For example, you can see the O1S6 on the survey 2 is all not at the right location of your page. So, and if you look at this here, that's all fine. But when you copy, then it all becomes a mess. So you can use this organization here to redo everything. And now this should be organized properly. Okay. And that's it. So my 6 is with the 6. And if you have a mistake in your file, that you have a data entry error, you can use this button here, which is a refresh Excel. So that will look at all the structures and see if there are any problems. Okay, and that's usually solving it. So after that, usually you save and you reopen the file. That should just have gone. So that's to sort all the errors. Okay, so this explains most of it. You obviously have to look at the nice KherveDB with, for example, if I again show something like iron and look at the 2p3 half, look at F203, that gives me the NIST numbers, and I can plot them, and they are now properly distributed. Let's say it's a bit easier if I show another one, but if you look at this one, this is the property page. On here I have Mark Bissinger's web page, which is on iron, on the thermal web page, which is on iron, and if I just click on silicon, it will reopen the page on silicon and on silicon. So basically you have the good 3 database into one, which is called KherveDB, and that explains the whole KherveFitting version 1.62.